An antenna tuner affects the heating and power handling capacity of the toroid in a balun or unun by altering the impedance match and SWR between the tuner and the antenna system, which includes the balun unun. Primary factor leading to increased heating and potential power issues in the toroid is a high standing wave ratio on the feed line between the tuner and the antenna. The purpose of an antenna tuner is to transform the complex impedance of the antenna system to a near perfect 50 ohm match for the transceiver. Before the tuner, towards the radio, a properly tuned system will show a low SWR. After the tuner, towards the antenna and balun or unun, if the antenna itself represents a poor match, example, a 600 ohm impedance or highly reactive load, the SWR on the feed line between the tuner and the antenna or balun remains high. High SWR is the main cause of issues because it results in substantial reflected power traveling back and forth on the feed line. This increases the total RMS current and voltage within the transmission line and the connected components including the balun and unun. High SWR means higher peak currents are flowing through the balance windings. Copper losses, that is I²R losses, increases significantly as current rises. The magnetic flux density within the toroid core increases with higher currents. Elevated flux density leads to increased core losses, primarily hysteresis losses, which generate heat within the core material itself. The combination of forward and reflected waves can also lead to very high peak voltages across the balance terminals, potentially causing insulation breakdown or arcing, especially in ununs designed for N-fed wires. The power handling capacity of a toroid is limited by its ability to dissipate heat without exceeding its maximum operating temperature, the Curie point for the material. Curie point is the point above which the material loses its magnetic property. For example, Curie point of iron is 770 degrees centigrade, while that of cobalt is 1115 degrees centigrade and nickel 358 degrees centigrade. The power rating published by manufacturers typically assumes a perfectly matched 50 ohm system, low SWR. When operating under high SWR conditions, the component must handle the sum of forward and reflected power, not just the net forward power delivered to the antenna. Excess heat can push the core material toward magnetic saturation. As the material saturates, its efficiency drops further, generating even more heat, which can lead to thermal runaway and eventual failure of the balun. To summarize, an antenna tuner doesn't directly heat the balun, but it allows the operator to drive power into an intentionally mismatched antenna system that forces the balun to operate under stressful high SWR, high current conditions. To mitigate this, ensure the balun unun is installed as close to the antenna feed point as possible, and ideally choose an antenna design that presents an impedance relatively close to 50 ohms before relying on the tuner for a perfect match. Selecting a balun with a core material rated for high power and frequency can also help manage heat dissipation.